Hi everyone, we start with Chapter 4, Operating System, User Interface, Compilers and Interpreters. What is the need for an operating system? Whenever you switch on any device, a computer, laptop, tablet, or even a phone, there is a software that loads into the main memory and makes everything possible, such as opening files, apps, saving text files, saving photographs, connecting to the internet, sending emails, even printing documents or scanning documents. So this is the operating system software, and some of the most popular operating systems are Windows, the Mac OS, Android, and Linux. So how does the operating system run a program? The operating system provides an interface between the application program and the computer hardware so that this application program can interact with the hardware only by the rules and the procedures programmed into the operating system. So this actually involves the creation of a process by the operating system kernel, which assigns memory space and other resources to any application. Now, what are the functions of the operating system? The main functions of the operating system are memory management, process management, file management, device management, handling input and output, network management, and error handling. So the memory management keeps track of mainly the primary memory and what part of it is in use by whom, what part is not in use, is all that it keeps track of. So if you're working on multiple programs simultaneously, the operating system will decide which process will be assigned memory, when and how much. And then it allocates the memory when a process requests it to do so, and it deallocates it when that process no longer needs it or has been terminated. So that brings us to process management. Basically, again, in a multi-programming environment, the operating system will decide which process will get how much time from the processor. And this is called process scheduling. So the activities of the operating system in terms of processor management are that it keeps track of the processor and the status of each process. The program responsible for this task is known as the traffic controller, and it allocates the processor or the CPU to every process that needs it. It deallocates it when that process no longer requires the CPU. We come to file management, which is basically organized into directories or folders, and that's how the operating system manages files. Basically, it keeps track of information, location, users, status, etc. And the collective facilities are often known as file system. And it also decides who gets the resources. It allocates and deallocates these resources. Network management is the process of administering and managing computer networks. It includes provisioning of networks, that is basically to set up the network, performance management of the network, fault analysis or troubleshooting any network, and maintaining the quality of service of the network. Error handling can occur at any time, and basically it may occur in the CPU or the input-output devices or in the memory. The activities of the operating system with regard to error handling is that it constantly checks for possible errors. It takes appropriate action to ensure correct and consistent computing. That brings us to the user interface, which is the means by which any user can interact with a digital device. Now, this is done with the help of some kind of input-output devices and a software. The usual human senses that I use to interact are touch, sight, and sound. but there is also smell, balance, and taste that have been included as user interfaces. So there is tactile UI, which is touch, visual, which is sight, auditory sound, olfactory user interfaces smell, equilibrial user interfaces balance, and there's gustatory, which is taste user interface. Let us look at the composite user interfaces, that is combination of more than one interface. That is, GUI is basically a graphical user interface which uses tactile and visual. Multimedia is when we add sound to the GUI, that is, it's tactile, visual, and sound. Some of the terms commonly used in UI are HMI, that is human machine interface, and man machine interface, MMI. The HMI interfaces machines with physical input hardware such as keyboard, mouse, or gamepad, and output hardware such as the computer monitors, speakers, and printers. A device that implements HMI is also called human interface device. Other terms used for human-machine interfaces are man-machine interface, and if the machine in question is a computer, it's called the human-computer interface, that is HCI. All user interfaces are designed keeping in mind efficiency of use, that is, the design should be user-friendly, simple, easy to operate. Ergonomics, the design should be keeping in mind ease of use and comfort. Accuracy, it should do exactly what is required and desired with minimal input. Psychology, it should be attractive, inviting for the end user. Inclusive, it should cater to the needs of differently abled. We now come to the last part of the chapter where we are going to talk about compilers and interpreters. We start with programming. Now, every computer programming language has a formal structure and character set that's specific to that language. So this is called the syntax. There's also the logical structure, which is called semantics. And programs are a set of commands and instructions whose execution is chained together. So it's basically for some kind of specific action which has to be carried out in order to solve some kind of a problem. So let's talk about computer program execution. The action described by the program are carried out or run by an executing machine. Specific effects are produced in accordance to the semantics of the instructions being executed. So the term run or execute basically refers to the specific action of a user starting that or invoking that program. A program written in any high-level programming language is called the source program or code. However, this cannot be executed directly by the computer. It must be converted into machine language to be executed. So the program is translated into a machine code, which is called the object program or object code. So the execution process by which a computer executes the instructions of this computer program are starting from the source code. It uses a language processor and then turns it into an object code ready for execution. So programs written in any programming language can be executed using special inbuilt language processors. These can be assemblers, compilers, loaders, or interpreters. So the compiler is a language processor that translates a complete program, the source program, as a whole and in one go. It has different stages. So the first stage is it starts pre-processing, that is replacing certain pieces of text by other texts according to a system of macros. Stage 2 has many sub-stages. That is, the compilation translates the source code into assembly instructions, which are later converted into machine instructions. Stage 3, the linking process establishes the connection to the operating system for primitives. This includes adding runtime libraries, which mainly consist of memory management routines. Now, the file is changed into an executable file or a .exe file, which can be run independent of the compiler. And it can be run many times with different inputs, and it can be run on any computer. So in the compiler, the errors must be removed successfully to recompile the source code, and it will continue doing it till the time the code is free of errors. So every time you run the program, you will see a list of errors, giving the line number, giving the error, and details about it so that you can use that information to correct your program. The interpreter, on the other hand, is a language processor that translates a single statement of the source code into machine code and executes it immediately before moving on to the next line. And its error statement comes as soon as it encounters it in that single line. When we remove that error, it goes further to see the next line and check whether that has errors. So every time we remove the error, the interpreter moves to the next line for execution. So the difference between the compiler and the interpreter is that the compiler converts the entire source code of a programming language into executable machine code for the processor. The compiler generates the error messages only after scanning the entire program. And it takes a lot of time to analyze the source code, but then the overall execution time of the program is comparatively faster. Some of the programming languages that use compilers are C, C++, and Java. The interpreter, on the other hand, takes the source code and runs it line by line, translating each line as it comes. And it takes a less amount of time to analyze the source code, but the overall execution time could be slower. And its debugging is easier because it continues translating each line of the program, and that can be corrected as it comes. The examples of languages using interpreters are Python and Perl. That brings us to the end of the chapter. I hope you understood. I hope you will continue watching and subscribe to the channel. Hope to see you soon. Bye-bye.